have like, she said like 50 odd games they have to play today.
50?
That's like 50 today or between the 2 days. They have to
Wow.
do on 6 courts.
That's a lot. Okay, well, 15.4, pretty short section. Do you guys have the homework assignment sheets?
Yep.
Yes.
Okay, you do. So correlation, 15.4. Correlation just refers to looking at data and looking at how it correlates. So not all data does correlate. It could be completely random. Some general ideas when you think about correlation doesn't have to be just mathematics, you know, thinking statistical data. You can think, okay, if I study more, my grade goes up. It can be kind of like logical reasoning. There's a correlation to that. The more you study, the higher your grades are. The more you read, the more vocab you know. So things like that. So correlation, though, does have an application to mathematics. And you look at data, and you can look at data and say, okay, if I see some data, so this is 15.4 correlation, and if my data looks like this, we would say that has a strong positive correlation. Okay, so strong positive correlation. There's something called the correlation coefficient, and that is then what they say is an R. R is the variable used, correlation coefficient, and if it's a strong positive correlation, R is close to the number 1. Now I'll explain how you get this value of R, but R will either be between 1 and -1, so it doesn't go to like 1.2, 1.7, or 2.9. R is between 1 and -1. So a positive correlation will have a positive value, close to 1. It doesn't represent the slope. It's not a slope of 1, because this could be really steep, it could be really gradual. But if it's data that looks like this in a positive slope direction, if you will, then it's a positive value of 1. So that's strong positive correlation. If you have data that looks like this, kind of squeezing it in here, I don't know. That would be, these are dots are kind of hard to see. That is, if you looked at it, you would say, okay, if I were to kind of draw a line through that, all these little dots, this has positive correlation, but is it really strong? We say, no, it's kind of like weak positive correlation. As you get weaker correlation, if you will, weaker positive correlation, the R value tends towards 0, or goes down towards 0, okay? So that would be like a weak positive. Strong positive, weak positive. But you can see the data is trending like in an upwards direction. When you have data like that, you would say no correlation. Now, there could be some sort of correlation, but it looks completely random and scattered. There's no correlation, and in which case your R value is really close to, what would you guess? 0, yeah, really close to 0. So R value is, and it could possibly be at 0, but when you do the, it's close to 0. When you do the, I don't want to put it in quotation. When you do the equation to find R, you're going to probably end up with like a decimal. It's hard to like hone in exactly at 0, but that would be close to 0. And then the last two would be if it's like this, your data, you know, like this, That's a strong correlation, right? Strong correlation, which direction? Negative, yeah. So strong negative, and what's your R value close to? R is close to? -1, yeah. And then your last one that we would discuss, you'd say, okay, I have values here. And weak negative, R value not close to -1, but not 0. So it's trending back towards 0. So weak negative in that case. Okay. So then, how do you find your R value? Now the nice thing for you is you're not going to have to do a bunch of labor-intensive work. I will give you the equation for the test, and the work in the book, they actually give you a lot of these values to plug in, so you don't have to find the values. But I'll explain where they come from. You can also use a graphing calculator. If we have time, we'll cover how to do that with the calculators. But you don't need a graphing calculator at all for this. So the equation that they use is R to find R, which is the correlation coefficient, which would tell you, hey, if I said R is 0.97, you would say, oh, if the correlation coefficient is 0.97, I know I'm looking at strong positive correlation. It's data that correlates, and I can estimate where, I can make some sort of estimation of the next value that it's going to be, as you can just track along this line here, right? So, okay. If I say, hey, it's like R is really close to 0, it's 0.2 or 0.1, you're like, oh, okay, there's not a lot of correlation going on. So that's what R tells you. So how do you find R? There's this equation. It says capital MXY and then minus MX times MY, or sub Y, I should say, all over sigma X times sigma Y. Now, again, I'm not going to make you memorize this, but you'll have to know, and when I say you have to know, they'll probably give you the values to plug in, like M sub XY is this, and you just plug it in. So what this is that capital M stands for mean. What does sigma stand for?
Standard deviation.
Yeah, standard deviation. So capital M X sub Y would be the mean of the product of the ordered pairs. So if you had these ordered pairs, right? So whatever this one is, 1, 4, 2, 7, 5, 6, I'm making up. What you would do is you would take 1 times 4, 5 times 6, 2 times 7, that would give you 14, 34, 1 times 4 is 4, right? And then you do the mean of all those. So if you had 50 data points, that means you'd have to multiply the 50 coordinates and then take the mean of all of those, which you won't have to do, but that's what you would do. And that would give you M sub xy. So the mean of all the coordinates multiplied together, right? So this, and then you find the average of all of them. M sub x, what do you think that is?
The mean of all x.
Yeah, the mean of all the x's, and then M sub y would be the mean of all the y's. So you take all your x values, find the average of those, take all your y's, find the average of those, and then take your averages and multiply them together. Subtract it from the averages of the x and the y. And then you find the standard deviation of just your x's, divide it, and then times the standard deviation of your y's, and then you would plug it into there. So if you had 50 coordinates to do, longhand, it would take you a long time. Because in order to find the standard deviation, you have to do the variance. So that would be really intensive. So you're not going to have to do that. But it's not hard work it just would be labor intensive. But it's not really confusing. And what do I do? You're like, okay, we just have to take a while. So that's to find R. Now, when we look at this, let's go back over here. I'll use a different colored marker. And green. If you look at this right here, with this right here, we could take and draw a, it's called two things. Line of best fit. I think that's what the geometry book called it. We did this in geometry, if you remember, Eliana, it all with the, it was in chapter 12. But it's called the line of best fit, or like more commonly in statistics, like regression line. And so the regression line is just a line that fits through your data. And so if you were to find the line of best fit, without using a bunch of equations, you couldn't actually find the line of best fit. What you could do is find a line that you think fits. The issue with finding a line that you think fits is you would have to graph the ordered pairs perfectly, meaning not estimated. And if you have large data, you're plugging in like hundreds, like 110, 120, how do you do that on some giant like graph paper, right? Or if you have data spread out over lots of different points, very difficult to do. But if you didn't and you were just estimating the points, then you could take a look, but is your estimation correct? I mean, it just becomes challenging. So you could do the line of what I think is the best fit, but it's not the line of best fit. Meaning, you could make errors without the equations, and your error would be, what if you chose this point and this point? Because you can always write the equation between 2 points, right? If you have 2 points, you can write the equation of a line. Review for the test, what do? For the final. To find the equation of a line, what would you do? And you have 2 points. Find the slope.
Or
Yeah.
distance form?
No, just not distance form, but you do find the slope that's perfect and then plug it into point slope form or slope intercept form and find the equation of a line. So that you could do. So with that, if you took these 2 points and you said, okay, now I've got the equation of a line that represents my data. False?
False.
Yeah, false. This doesn't represent your data at all, right? Because your data is going which way?
Positive.
Yeah, it's going up that way. So if you're like, all right, this line represents it, when I plug in something out here, I'm going to get something way down here that has nothing to do with my data. So you're completely off. So estimating can run into major errors. Or even if you said, okay, what if I choose this point and this point? Well, it's better, but according to my data, is it really that accurate? No, because if you pick a point out here and plug it into your blue line, you're here, but your green data says, hey, I should be up there. You're way off. So then you try to pick a point and you're like guessing, like, well, what about this point and this point? And you're like, okay, that's going to be pretty accurate, and so you're maybe not the line of best fit, but you're getting a better line of fit. But that's, that can be challenging to do, especially if you have to estimate all these green dots. If you have 50 points to graph, that can be challenging, right? So that's why we have equations that they come up with that say, hey, you don't have to find 2 random points. We're going to actually find the average of all the points, and then we're going to find a slope using our correlation coefficient that tells us where it should go. And that will find the line of best fit that represents the data the best that it can. Now with that line, you're still going to be off, because if you plug into the line, like plug in over something and up something, your green dots, this green dot may be here, but the blue dot is going to be right there. So you're a little bit off because there's no way for a line to fit into all these points. That wouldn't be a line. So it's the line of best fit, but it's not necessarily exact, but it gives you a really rough estimate, very close estimate of what your data should be doing. Now, if your data has a really weak positive correlation, your line of best fit works, but it's not that accurate because it's weak correlation. With no correlation, there's no line that fits, right? So it doesn't matter. So, but with a strong positive, the blue line trending in that direction is give you a really accurate, hey, if I plug in a different point, what am I going to get back out? I'm trying to estimate, okay, if you plug in this, you're going to output this. I feel good about that. Here, you're like, yeah, if I plug in this out here, it could be here, 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 here. The blue line says here, but I know I've got some variance in there. I'm not exactly going to, it's not going to exactly be perfect. And they would use this type of thing too when you're looking at data. I don't, not to harp on the goat thing, but if you have like, hey, goats that produce milk and you're trying to like run a goat dairy farm and make money off of that, you're going to figure out how many goats produce this much milk, and you're going to, okay, this goat produced this much, this one produced this much, this one produces this much. Is there a correlation? And there should be. So you're like, hey, if I have 50 goats and we're going to get this much milk and we can sell it for this price. If I raise it up to 60 goats, what's my estimate going to be in sales? And you do all this stuff. If you have really random, completely random data, and it's like, I don't know, this goat does 10 gallons, this goat does 1 gallon, this goat does no gallons, this goat does 15 gallons, I don't know, hope I get the right goat. You can't run a business that way.
They do that actually the same exact thing. They do competitive milk certification, so it's that exact thing. Like they have charts and stuff, and like when you register your goat, it's like you can competitively test it for that sort of thing.
Yeah, right, because it'd be important for if you're trying to make money off of it. Yeah, so you would have that type of data. But if there's no data, then it's not helpful. So they have data for these types of things. Okay, so how do we get our line of best fit? Well, to write the equation of a line, to get the line of best fit, you need a point and you need a slope, right? That's how you find the equation of a line. Well, again, we could pick two random points and hope that we pick the right ones, and then you would find the slope, and then you plug in a point slope form. That's not what we're going to have to do here. They're not asking you to do that because they're going to give you the point. So the point that they're going to use is m sub x and m sub y, and that's the best point to use, meaning it's the average of all your x's and the average of all your y's. But it actually makes sense that if you average all your x's and average all your y's, that would represent a point that will give you the best data. Now that's only one point, right? So if you had the data here, let me just draw something over here, and you have all this data, coming like this, okay, and you do m sub x, m sub y, like that. So you take all your x values and you do the average, all your y values do the average, it's going to give you a point. That point, if you estimated, that point is probably going to be right there. So now you need to know which direction to go from there, right? Well, the correlation coefficient, like an R value of 1, that's not the slope, right? 1 isn't the slope, but the correlation coefficient tells you, is it strong, like a really good connected slope? Is it weak? Is it going in a positive direction? Or is it going in a negative direction? So in the sense of the positive and negative, it does tell us the slope, but the correlation coefficient is going to help us. So how do you find the slope? So the slope m, little m, and maybe I should write slope, right? So that you don't confuse like mean or something, is equal to r times, so you take your correlation coefficient, and it's sigma y over sigma x. So, over x, which is slope, right? Y over x. And then so you take sigma y over sigma x, multiply it by r, and that will give you a slope. Again, if you have 50 data points, you'd have to do all this work, but once you did this work, you'd have the mean of x's, mean of y's done, and then you'd have sigma x and sigma y done, and then the r value would be by doing that. You're not going to have to do that, but you have all that to find this and this. Once you have this, you have to remember what to plug into, which is y minus y1 is equal to m times x minus x1. Or you could plug into y equals mx plus b, and you would have your slope to plug into here, and you would have an x and a y to plug into there, and then you could find b. That's back from our Algebra 1 days and review from this year at some point, chapter something. So, Eliana, you have a question?
Yeah, so with the standard deviation, like sigma, would we do the equation from the other one with all the x's?
Yeah,
What
you
the
do the
variance
score. Yeah, you'd have to find. You would have to find the variance, and then take the square root of the variance. So you take each score, subtract by the mean, square it, take it,
Yeah.
and then divide it by the total number and everything like that. Yeah. So in this case, they're not going to have you do that. You only have a couple problems to do, and in those couple problems, and we can look here in the book, they just tell you what this is, they tell you what this is, and what this is, and what this is, and what this is. So you don't know any of your data points, they just give you all those, you plug it in, hit enter. So, which is fine, it's no problem, we don't need to do, I mean, it could have some value, like, all right, here's 10 points, find all those. But it's okay, they don't give that, I'm not gonna make you do that. Okay, so then let's talk about, like go to page 727 and let's look at your homework. It says draw a scatter plot. So we haven't not talked about drawing a scatter plot, but a scatter plot is just what I was drawing up here. But this would be with actual data. So a scatter plot, the idea is that you're going to have to make some estimates because it's not like over 1 up 2, over 3 up 5. Its values, like on number 1, they have the congressional elections for 6 consecutive elections, registered to vote 70%, and then those that actually voted is 55% for the last for the last 6 consecutive elections. And so what they're looking at is the registered voters compared to the actual the percentage of people that actually voted. So they have this chart, right? And you can look at it in the book. This is number 1, and so the chart is percent of registered, and then the percent of that actually voted. So there's people registered to vote. So then the first number is what? Is it 70 and 55? Then it's
68, 55,
68. What?
55.
55.
62, 45.
62, 45,
63, 46.
63, 46,
64, 49. And 64, 46.
64, 46.
Mm-hmm.
So what they're stating here is that you are looking at a XYT chart, right? So they're just stating, hey, if you have 70%, so then you would state like percentage of registered voters. So percent registered to percent voted, and you would just have to make up your graph here. You're probably not going to go 1, 2, right? Because then you're drawing out. So one thing you can do to represent is you can go like, I don't know if you've seen that, something like that. Wow, that's really janky, but like that. Have you seen that where there's like a little squiggly at the beginning? What that represents is that there's a bunch of data, and then you're just starting out here at like the lowest value is 62. So maybe you go 60, 61, 62, 63, 64. 65, 66. I mean, if you want to, because you only have to get up to where? 67, 68, 69, and 70. So you only have to get up to 70. Now you could go in twos, like 60, 62, 64 if you wanted to. But that would represent that, hey, I'm doing actually by ones, but obviously from 0 to 60, I'm not going to draw that. So that's and then from here on up, you see you're going from where 45 is the lowest. So maybe the first one's 45, and then you're going all the way up to how high? 55. So, 45, 45, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is up to 55 right there. Okay, so then that's a scatter plot is where you're just you're going over 70, up 55, right? And then you're going over 68, up 55. I mean, this is, again, estimate. Maybe I'm a little bit off here. I'm trying not to get in the way of the camera, whatever. 62, up 45, 63 up 46, 64 up 40, you said 49. 5, 4, 3, 2, 1, 0, 49. Like that, and then 64, 46. Kind of way down, 64, 46, like that. So there would be your scatter plot. And don't worry about getting too detailed on it, you know, when you go to do these. And so there would be your scatter plot. So if you were to guess, there's not a lot of data, right? Only 6 years worth, but if you were to guess, is it strong positive, strong negative? Well, let's start with this, positive or negative?
Positive.
Positive, right? Yeah, you can say, okay, as I'm going up, the more people registered to vote, the higher number percentage of people that voted. It makes sense there too. And then with that type of data, it almost looks like it could be strong, but there's this like weird gap here, where maybe that's some of this my drawing, but between 62 or 64 and 68, you know, there's no data, and you know, nothing going on in between there, and then there's kind of this big jump. So your R value,
Probably say weak positive.
maybe weak positive, because it's kind of, but it does look like it's trending, you know, you could connect, so it could be kind of an in-betweener. So if I'm not gonna, like, if I put that on the test and said strong positive, you know, what do you think it is? The key would be, yeah, it's positive, and I don't know, weak, strong, hard to tell, because you don't have a lot of data. Now, if we wanted to find out what R is, we just simply do this. So I am kind of curious, since there's 3 of us, Eliana, do you want to find the average of X times Y? So just go, these multiply together, right? All those, and then add up all of those scores, and then and then divide by, how many scores do we have total, right? 6?
Yeah.
And then Miles, do you want to find the average of your X's and the average of your Y's?
Yeah.
So just take this, find those,
Average of that.
average of those, and average of those.
Okay.
Okay, get those, and then we'll talk about the variance, because we need the average of the X's and the average of the Y's before we get variance. Did you find it?
Probably not. I multiply like 70 and 55, then I add it to 68 times 55.
Mm-hmm.
Okay.
And then add it to 62 times 45, and then divide by 6.
Yeah.
Alright, so what did you get for?
3,226.3.
What is it?
3,226.3.
Okay, what did you get for M sub X?
M sub X, 65.2, that's rounded.
Okay, that's fine.
And then M sub Y is 46.
Okay, and both those are easier to see, that looks to be accurate. Harder to know on this because you have to do some multiplication, but you know, 70 times 55 is going to give you
380. No,
What is it?
not 3,080.
3,080.
Yeah, 3,850.
3,850.
Yeah.
Right, so that tells you right there, that's in the 3,000s. So multiplying all those together, it seems like that may be reasonable for finding that to be the average. Okay, so now to find sigma x and sigma y, okay, meaning standard deviation. Miles, why don't you do sigma x? Eliana, you do sigma y. And how do you find that? You say, okay.
Square root of, yeah, all the x's.
Yeah, so sigma x is going to be the square root of each score minus the mean, 65.2, right? Squared plus 68, it's gonna, minus 65.2 squared plus at the top, all divided by 6. And then with the y's, you just do that, but with the y values, 55 minus 46 squared plus dot dot dot, all divided by 6. And you're not gonna have to do this for all of them, but I just wanna see what this gets. Okay, did you get sigma x?
I thought I was doing Y.
Or sigma y, I'm sorry.
28.6.
28.6. That doesn't seem accurate.
No.
Because that says on average, each y value was 28.6 units away from the average of 46. And if you look at the y values, none of them are 28.6 away.
Okay.
So that's okay. Let's, Miles, what did you get for sigma x?
1.3.
1.3. So think about that. If the average is 65.2, on average, everything is like 66.5 or 63.9, which actually seems to make sense because everything's right around 65.2, right? Except 70, but that's why your standard deviation goes
an
up.
outlier.
Yeah. Okay, so that seems to make sense. Eliana's is not quite making sense, so let's help Eliana out.
I think a decimal.
Did you divide it by 6?
And then take the square root.
Oh wait,
I did not take
no.
the square root.
What, did you subtract it?
No, I forgot the square root part.
Okay, even so. Wait a sec.
Even so, that may be a little high. So let's just redo it. That'll help us out here as well. 50, oh, the mean is 46, right?
Yeah. So that one gave me 5.4. That's not right either.
5.4 doesn't seem accurate either. That's with the square root, right? That's what
Yeah.
the square root was.
What's the 5th variable? 49?
Yeah, that's what you told me, and in the book, that's what it is.
Okay.
Although with two scores of 55, that is possible. Thinking about it. This is not in the back of the book, because they don't ask for that.
I got 5.9.
Which is what Eliana got, right?
I got 5.4.
I had, let's see here. Yeah, I got 5.9. Cause I had 9, 11, 1, 0, 3.
I got 5.4.
5.4, okay, I'm probably off then.
Where'd you get Eliana?
5.4.
Okay, so we'll go with 5.4, which, if the mean is 46, on average it's either at 51 or down to 41. I actually don't know if your average is correct. 55 plus 55 plus 47
Is that
plus 46
35?
plus 49 plus
That's 50.
6 divided by 6. Yeah, the average is 49.3. You can check it. 55, 55, 45, 46, 49, 46. 55, 55, 45, 46, 49, 46. So the average should have been 49.3, which makes more sense. So now, if we go back up, go ahead. Here's the work. You just have to change on your calculator. Depends on how your calculator operates. Mine's very slow in getting over there. Well, you know what I should do is just change every mean to 49.3, which is going to mess up my calculator, but that's okay. Maybe your calculator is faster. I'm making slow headed. Which makes me wonder, is our average of the x's correct at 65.2? I'm still slowly replugging it in. 49.3. I got 3.96.
4.3.
59 minus, I'm sorry, 55 minus 49.3, right?
Yes.
Six. 49 minus 49.3. 40. You know what I'm missing? I wonder if I'm missing.
What?
I think I'm missing one more in there. This is just cumbersome on the calculator. Okay, I have 55 minus 49.3, check, squared, plus 55 plus 49.3 squared, plus 4.2.
4.2 is what we got.
45 minus 49.3 squared, plus this cumbersome of a calculator. I think I skipped this one, 46. Cause I have 49 and then I only have 146. None of the 46s, okay. So I skipped one. Which I would need to add in there, plus, parentheses, 46 minus 49, 3, and parentheses squared, divided by 6.
And this would be only for the first 4 problems?
No, you don't have to do this at all.
He just wants us to graph, plot, and then describe it.
Right.
And so I can't even get that, and for some reason my calculator is like on overflow or something. So, with that being said though, we're gonna trust, what you said? 4 point what?
2.
So if you plug all that in, okay, then you would take, 3226.3 minus 65.2 times 49.3, and then divide that by 1.3 times, what is this? What did you say, 4 point what?
4.2.
4.2. 2.2, which is also wrong because R can't be 2.2. So, somewhere along the way, we messed up. Somebody, one of us messed something up in there. Good thing you don't have to do that. But we can come back maybe Monday, because I am curious now where we messed up. I want to know what the correlation coefficient is. Because I'm curious strongly. You don't have to do that through 1 through 4, right? You just have to do the scatter plot. I just wanted us to figure out, oh yeah, the correlation coefficient is 0.9 or 0.2, and say, yeah, that makes sense, see what it is. Okay. So we'll have to come back and revisit this. So, okay, but you can work on the rest of the stuff, no problem. Won't be due Monday. We will let it due on
Tuesday?
Okay.
Very good.
Thank you.
All right.
Thank you.
Have a great weekend, you guys.